Okay, so in this video, we're gonna go over the video version of the study guide. So it's very similar to the study guide given out during class. So in this, so this study guide has is worth no credit. Okay, so before we start, no credit. However, this study guide is very similar to the one given in class, and if you're able to do this problem or any of these problems, they should link up or they should align really well with the previous given study guide. So again, this is the video version. I rewrote the problems to be very similar to the ones in the study guide. Okay, so before we start, let's do some notes on polynomial operations. So whenever we want to add polynomials, we want to, let's see if this is coming up, combine like terms. And when I'm talking about combining like terms, it's just like, we're not going to combine something like this, right? Because they're not like terms. Like terms would be same exponents. So we're going to combine terms that have the same exponents. So here we can't combine it. But if I made this x squared, now we could combine this into 6x squared, right? So keep in mind when we're adding polynomials, we combine like terms and we keep the same exponents. For subtraction, we want to get in the habit of distributing the negative to each term. And to do that, we want to use parentheses, right? So we want to put them in parentheses. So an example of this would be, I'm doing negative x squared plus 2. If I want to, and let's do this. So then this becomes x squared, the same. And now we're going to distribute the negative to each term. So then this becomes negative times x squared is negative x squared. Negative times positive 2 is negative 2. And then you could just simplify afterwards. So we want to distribute the negative and we want to use parentheses whenever we are subtracting. Okay, for multiplication, this one, let's keep it simple. Let's put distribute 1 at a time. So let's see, one term at a time. So if we have something like 3x plus 4 and 5x plus 7, I want to distribute the 3x with the 5x, then the 3x with the 7, and then the 4 with the 5x, and then the 4 with the 7. And when we talk about distribute, it's always multiplication. Okay, we'll get into some problems going over distributing, but let's keep that in mind. And then last one, for the division or factoring polynomials, for division specifically, you can either do long division or synthetic division. And when we're talking about factor, before we do anything, we always look for GCF. So this is the greatest common factor, right? So if I had the problem 3x squared plus 6, the greatest common factor would be just, yeah, that's a good one. 3x squared plus 6, the greatest common factor would be 3x, and then the inside becomes x plus 2. Okay? Okay, so now let's do example 1. So here, example 1, let's read it. Forestville Student Council is selling spiritware. They currently have 500 large items. So here, I'm going to underline some important things that we need to take out. So the first sentence, Forestville Student Council is selling spiritware. That's not telling me anything. So I'm going to cross it off. They currently have 500 hoodies, large items, 80 t-shirts, medium items, and 40 stickers, 80 items. Okay. Next, a new shipment arrives. So a new shipment arrives, and it has 800 hoodies, 150 shirts, and 30 stickers. And then at noon, a large group of students purchases 300 hoodies, 50 shirts, and 50 stickers. So purchase. Use function notation and polynomial operations to model the inventory. Okay, so here we have 500 hoodies. We currently have 500 hoodies, 80 t-shirts, and 40 stickers. So we have large items, medium items, and small items. So the way I'm going to write this is, or the way I'm going to model this using a function is, I'm going to write 500 hoodies x squared, and I'm going to let x squared represent my hoodies, and then 80x to represent 80 shirts, and then 40 stickers. And I'm just going to leave it as a constant. Okay, that's the one in red. The new shipment is the 600 hoodies, the 150 shirts, and the 30 stickers. And lastly, the purchase, the one in green, is 300 hoodies, 50 shirts, and 10 stickers. So this is my current. The blue is my new, and then the green is purchase. So we, at 8 a.m., we started with our current inventory, and then a new shipment arrived. So we're going to get more stuff, and we're going to be adding it. That's why we have a plus. So if we add these two, well, I can't combine the 500x squared with the 150x, just like how I can't combine 500 with the 30. When I add these polynomials, we always look for the same exponents. So this one, x squared, I'm going to look at the other term and look for an x squared. Here, this one doesn't have an x squared. Neither does this one, but this one does. So I'm going to do 500 plus 600. 500 plus 600, and that should give me 1100 or 1100. Then I'm going to do 80 plus 150 to get me, what is this? 230. 230, and then we have 40 plus 30 to give me 70. Okay. So I'm just gonna highlight my answers. That one, that one, that one. Okay. So that was at 8 a.m. There should be 8 a.m. here. At noon, complete a subtraction problem using the results from part A and the purchase. So at 8, we had 1,100 hoodies, 230 shirts, and 70 stickers. Okay. Then at noon, we had some students purchase some items. So this means we're gonna take away 300 hoodies because they bought 300 hoodies. We're gonna take away 50 shirts because they bought 50 shirts, and we're gonna subtract 10 stickers because they bought 10 stickers. So we're gonna have to distribute this to each one. And when we just have a negative, we have an invisible one. So we have -1 times 300. It becomes -300x squared. And -1 times 50x is -50x. And then negative times 10 is -10. So then on the side, we're going to do some calculations. I have 1,100, and we're going to subtract 300. And what does that give us? It gives us 800. Okay. Now we're going to do 230 minus 50. That gives us, what is that? 180. Okay, and then we have 70, and then we subtract 10. That gives us 60. Yes. Okay, so we have 800 hoodies. And remember, we denote x squared with hoodies. We have 180 shirts, and then 60 stickers. Oh, that should be plus. Okay. Now, that's it for example 1. Okay, let's do example 2 now. So here, I'm gonna write, whenever I see f of a, I'm gonna write it in red, and when I write g of a, I'm gonna write it in blue. Okay, so number 2a, we're doing f of a plus f g of a. So we're gonna write, I'm gonna rewrite this, but instead of f of a, I'm gonna write what f of a is equal. So this is going to be 3a squared plus 4a. Let me write my a's a little bit different. So 3a squared plus 4a plus g of a, which is 6a squared minus 3a minus 8. Okay. And this is equal to, well, first, is there anything being distributed in the front? Is there anything being distributed to this term or this whole term? No, we only have a 1 and there's no negative. So essentially what we could do is we could just drop the parentheses. So we have 3a squared plus 4a. Oh, I said drop the parentheses. Plus 6a squared minus 3a minus 8. So we have 3a squared and then plus 6a squared. That gives us 9a squared. And then we have 4a minus 3a is 1a. And then the only thing left is -8. Okay, now we're going to do the exact same thing. We're going to do f of a, which is 3a squared plus 4a, right? 3a squared plus 4a minus g of a, which is, again, going back over here, we have to use parentheses. So I'm going to put it in parentheses, 6a squared minus 3a minus 8. And now we can distribute this negative to each term. And let's rewrite this. So here, there's nothing being distributed. So we have 3a squared plus 4a. Negative 1 times 6 is negative 6a squared. Negative 1 times negative 3 is positive 3a. And then negative 1 times negative 8 is positive 8. So now we have 3a minus 3a squared. So negative 3a squared. Then we have 4a plus 3a gives us 7a. 7a. And then we have plus 8. Okay, so here was my answer for number 1. Then number 2. And then let's do the last one. We have 3a squared plus 4a times 6a squared minus 3a minus 8. And then here, when I'm multiplying these two, you could FOIL each one out and then do it that way, or you could do the box method, which is, we could do, let's do it this way, 3a squared plus 4a. And then here, blue is 6a squared minus 3a minus 8. Then the box method is just, so 6a squared times 3a squared. Well, 6 and 3 is 18. And then when we multiply powers of a or powers of x, we just add the exponents. So a squared times a squared is a to the 4th. And then 3 times negative 3 is negative 9. A to the 3rd, because a squared times a, we just add up the exponent. This is a invisible one. 1 plus 2 is 3. Now negative 3 times negative 8 is negative 24, and we only have a squared, since this one has no a's. Positive 4 times 6, 24. And then a times a squared, add up the powers, a to the 3rd. 4 times negative 3 is negative 12. And then a times a gives me a squared. And lastly, 4 times negative 4 gives me negative 32a. Okay, and to finish up the box method, I just add up my terms. So here, top left, I have 18a to the 4th. Well, do I have any a to the 4th? No. So I have 18a to the 4th. And now I'm going to do the next one. Negative 9a to the 3rd. Do I have any other a to the 3rds? This one. Okay, so if I add these up, I get positive 15a to the 3rd. Next, I'm going to do negative 24a squared, and then looking for a squared, I only have this one. So negative 24 plus negative 24 gives me negative 36a squared. And then lastly, we have this negative 32a. So then my answer would be this. So here equals this. Okay, looking at number 3, we want to completely factor this expression. So we have f of x is equal to 4x squared minus 24x. Okay, so remember when we're factoring, we want to always look for our GCF first. So what that means is our greatest common factor, or something that goes into the first term and the second term. Here we have an x squared, and this one we have an x. So we know automatically we can factor out an x. Okay, next I want to figure out, okay, what number can I pull out from both of these? Looking at 4 and looking at 24. Let's do some multiplication trees. So we always start with 1 and 4, and then just start increasing in numbers. So 1 times 4 gives me 4. 2 times what gives me 4? Well, 2. And then 3 doesn't go into it. And then if I do 4, well, it's over here already. Here, 2 and 24. We can break it up as 1 and 24. And then 2 and 12. And then 3 and, what is that, 8? 8. And 4 and 6. I can't do 5. And if I do 6, well, now we're back up here. And what we're looking for to figure out what our GCF is, I just want to look at the highest number that is in both of them. Here, I have 1 is in here and 1 is in here. But so is 2, and 2 is higher than 1. So we're going to look at 2, okay? But if we look even more, we know 4 is in here and 4 is also in here. So I'm going to look at this, and I'm going to look at this. So since 4 is the highest number that is in both our binary trees or multiplication trees, we're going to take out 4. And then when I factor out 4, I'm left with 1x, because we also took out an x. And then when I take out 4 from 24, I'm left with 6. So minus 6. And then just writing this a little bit neater, we can write this as 4x, x minus 6. Okay, example 4, factor completely g of x, x squared plus 7x minus 18. Okay, here is where we're gonna have to recall a bit on how to do factoring. So we're gonna use the diamond method. So we're gonna draw a big giant diamond, and then the top is always gonna be my first times my last. So my first is the number, our leading coefficient. So this is an invisible 1. And our last term is this negative 18. So it's going to be 1 times negative 18. Okay. Oh, I forgot. So here we said we always want to look for our GCF. So always look for a GCF. We didn't even do that. So let's back it up a bit. So we have 1x squared plus 7x minus 18. So can I take out an x from all 3 terms? Well, this one has an x, so I can take out an x. This one has an x, so I can take out an x. But this one does not have an x, so I cannot take out an x. Okay. Well, 1, 7, and 18. Well, 7 is a prime number, so it has no other factors besides 1, right? 1 times 7, and then I can't break it up anymore. And then 1, well, 1 can only be broken up with 1 and 1. And then 18, well, the highest number would be 1, right? So it doesn't matter what factors 18 has, I won't be able to factor anything out. Okay, so we have a GCF. We cannot take out a GCF, so we could continue. So if it did have a GCF, like number 5, then we could factor out GCF and then factor. But here, we don't have a GCF, so we could continue. So going back to this diamond method, first times last, so 1 times negative 18 gives us negative 18. And then we want something to add up to 7, to positive 7. So looking at 18, we have 1 and 18, 2 and 9, 3 and 6, 4 doesn't go, 5 doesn't, and then 6, we're back up here. So we got to look at these factors. What two numbers multiply to 18 but add up to positive 7? So this has to be negative, right? So if I do this one, they add up to they multiply to negative 18, but they don't add up to positive 7. They add up to 17. So this one's not it. Maybe this one. We could do a negative 3. No, that's not gonna work. We could do this one a negative. Also not gonna work. Okay, now let's do this one. 9. This one works. So I'm gonna write it in blue. So negative 2 and positive 9. They multiply to negative 18 and add up to positive 7. Okay, so we're gonna go back over here and we're gonna write x squared, and then instead of 7x, I'm gonna write I'm gonna use my two numbers. 7x, instead of 7x, I'm gonna write minus 2x plus 9x. Okay, and then the last one, minus 18. So we replace 7x with negative 2x and plus 9x. Okay, now this is going to lead us into factoring these two. Okay, so then our next step is going to be look at the GCF of each term. What can I factor out? Here, this one has an x squared, this one has an x. Oh, I can take out 1x. Can I take out any numbers? No. So I'm going to be left with x minus 2. Okay, and now we're going to look at the next one. Oh, okay. And then what can I factor out from these? Well, 9 goes into 9, but 9, we also saw it goes into 18. So we can take out a positive 9, and I'm left with an x. And when I factor out a 9 from 18, I'm left with a negative 2. So negative 2. And now to complete our factoring, I just write this. Do you notice that this term and this term, x minus 2 and x minus 2, they are the same? These will always be the same every single time. Okay, so these two are always the same. If it turns out you have something like a positive 2 over here, well, now they're not the same. So we did something wrong over here. Or maybe we did something wrong over here. But the point is, if these are not the same, we did something wrong, and double check your work. Okay, continuing this. Since we have x minus 2 written twice, we're going to factor that out, and we get x minus 2. And then if I erase this, I'm left with x. And if I erase this, I get positive 9. And then this would be my final answer. Okay, let's do example 5 now. We're looking at h of x is equal to 3x minus 18 plus 27. So here, before we do anything, we want to look for GCF. we have 3, 18, and 23, 27. Well, first we notice that this has an x squared, this has an x, and this has no x's. So we know no x's are going to come out in our GCF. Okay, this has 3, that is 18 and 27. What can I factor out? Let's see. 3, 18. So we know 3 times 6 is 18 and 3 times 9 is 27. So we can factor out 3. So we're going to equals. We're going to factor out 3. And what am I left with inside? So when I factor out my GCF, I like to think of it as multiplication. So 3 times what gives me 3x squared? Well, 3 times x squared gives me 3x squared. 3 times what gives me 18? 6. And then don't forget the x. Then 3 times what gives me positive 29? Plus 9. Okay. From here, now I can do the exact same thing. Diamond method. First times last. Right? This is going to be the first of my blue. So 1 and then 9. So we get 9 and then it has to add up to negative 6. So let's see. 9 can be broken up as 1 and 9, 3 and 3, and oh, there it is. We could do negative 3, right? Negative 3 times negative 3 is positive 9, negative, negative. And then if we add these two, we get negative 6. Okay, so then we can write this as 3, and then parentheses x squared minus 3x minus 3x plus 9. Okay, and then continue breaking this up. Right, we group the first two and then the last two. And then let's look at this one. So here I can factor out a 3. So let's do this on this side. Let's do x squared minus 3x minus 3x plus 9. We factor the first, we group the first two, the last two. We take out 3, we get x. Oh, we could take out x as well. So 3x minus 1. And then here, if I factor out only a 3, we're going to get negative x in front. I don't want that. I want it to be positive. So I'm going to factor out a negative 3. Oh, wait. We can't factor out 3. What? I'm crazy. This one has a leading coefficient of 1. So we can only take out an x. Here. Oh, that's going to change my answer. Okay. So I can only factor out 1x. And I'm left with x minus 3. And then here we have a negative 3x plus 9. And if I only factor out a 3, I am left with a negative 1 in front. So we want to make this one negative to make this one positive. And now, okay, now it works. This and this are the same. So we write it once, x minus 3. And then scribble this one out. I'm left with x. And then scribble this one out. I'm left with this. So we have 2 of these. And we could denote this as x minus 3 squared. Okay, so now we come back and we write x minus 3 squared. Okay, number 6. First, look for GCF. We have a 2, we have a 1, and negative 3. So these, it doesn't look like there's a GCF, right? 2 can only be broken down into 1 and 2. 1 can only be broken down 1 and 1, and 3 can only be broken 1 and 1 and 3. So there's no number we can pull out. What about our x's? This one has an x squared, this one has an x, this one has no x's. So no x's. So there is no GCF. Now we just continue with our factoring. So again, let's see. I'm running out of space. Let's do our diamond. We're gonna do first times last. So the first number here is a 2. The last number is a -3, so this gives us -6. And again, this needs to add up to the 1 here. And we gotta figure out what numbers go there. After some work, we could do 3 and -2. +3, -2 gives me -6 when I multiply, and 1 when I add them. Okay, so then what is this? I of x, okay, 2x squared, and then we're gonna do plus 3x minus 2x minus 3. And then we're gonna group the first two, the last two. The first two, I could factor out 1x, and I'm left with this 2x plus 3. And then here I can factor, we want to make this one negative, right? If it has a negative in the front, I factor out a negative. So we're going to factor out a negative. What do they have in common? 2 and -3. They have nothing in common. So I can factor out just a -1. So then this becomes 2x plus 3. And look at that. 3x plus 3, 2x plus 3. And then let's take that out. What do we get? 2x plus 3. Scribble that out. What do I get? X. Scribble this one out. -1. There we go. All right. Number 7. Factor completely. So we have 3x squared plus 8 minus 3. So 3 goes into both of these, but it does not go into 8. So, this x goes into that and that, but not this. So we don't have a GCF. We can't factor anything out. So then we could continue with our next step, which is the diamond method. First times last. The first is a 3. The last is a -3. So 3 times -3, -9, and we have a +8. So +8 goes up here, down here. Let's see. After some work, we could try different numbers. We go with +9, -1. They multiply to -9, and they add up to +8. So now we can write this as j of x is equal to 3x squared plus 9x minus 1x minus 3. Group these two, group these last two, the first two, last two. What can I factor out? Okay, here we can factor out a 3 because 3 goes into 3 and 9. And they both have an x. We can take out an x. So now 3x times what gives me 3x squared? Well, what's the only thing missing? Just an x. And now 3x times what gives me positive 9x plus 3. Okay, we're done with the first group. And now again, this one has a negative. So I want to factor out a negative for sure. And we have a 1, we have a 3, they don't have anything in common. This one has an x, this one doesn't. So again, we're going to factor out -1. I'm left with a x plus 3. And again, these are the same. So I can factor out x plus 3. And then scribble this one out. I have 3x and then scribble this one out, -1. There we go. Okay, now we're going to move on to transformations, or transforming functions. So this is unit 1, the very beginning of the semester. So for translations, these are, let's do it in red. Translations, they are the same thing as shifts. So meaning we're just moving the graph up or down. We're not doing anything else. So this is either up or down or left and right. So if we are inside the parentheses, so x minus h, this is a horizontal shift and always going to be opposite of the sign. Okay, so what I'm talking about, I think the next few problems will go more into detail about those, but let's finish our notes here. So if it's inside our parentheses, it's a horizontal shift, so meaning it's going to go left and right, and then we're going to do the opposite of whatever the sign is doing. If it is outside our x minus h, so plus k. So we're looking at this. If it's outside the parentheses, it's gonna be a vertical shift. Okay, and moves with the sign. So meaning if it tells you plus 10, that means 10, move 10, positive 10. And since it's vertical, if we have a plus 10, that means shift up 10. If it's inside, we have a x minus 10. It's going to be a horizontal shift, so it's going to be left and right. And it's going to be the opposite of the sign. So if it's x minus 10, it's going to be moved to the right 10. Okay, so reflections. Let's see. I don't have enough room for this. Reflections, a negative f of x. So if we have a negative in front of our function, it flips it over the x-axis, right? So I recall, actually no. So it flips it over the x-axis. If it's inside our function, it's a flip it over the y-axis. Okay, and then stretch or shrink. If it is a fraction, it is a shrink. If it's a number bigger than 1, it is a stretch. Okay, so let's do example 8. Let's see. Let's see that way. Okay, describe each of the parent function p of x is equal to x. Describe each transformation of the parent function. Okay, so this is my parent function, defined by f of x is equal to p of x. Okay, all that garbage. Okay, so let's try to piece it together. Multipliers first. When you think of multipliers, what do we think that is? It's something that's getting multiplied by. Okay, so here my multiplier is going to be this. What is my p of x being multiplied by? We have a multiplier of 2. So this means it's going to be a stretch by a factor of 2. Next, we want to identify additions and subtractions. So here, what is this doing? Well, it's an inside. It's inside. So which one is it going to be? It's going to be inside, and we're going to do the opposite of the sign. So here, this minus 4, that's going to tell us to do a shift. And then since it's a negative 4, we want to think left, but it's going to be the opposite sign. Remember, the opposite of our sign. So shift right by 4. And then this plus 10. Plus 10. So is this inside or outside our function? It's outside. So we have a, let's write it as this, inside negative 4, okay, and then the outside plus 10. So that means shift, and then we do exactly what it tells us to do with the sign, and it's gonna be a vertical shift. So shift up by 10. Oh, sorry, this goes right here. Right here. Sorry. So outside plus 10, shift up by 10. Okay, and then the very last thing it's telling us to remember always solve for x. So that means this part. So we have x minus 4, we set it equal to 0, and then we get x is equal to 4 by adding 4 to both sides. Okay. Okay. Example 9. Let's see. Describe each transformation of the parent function x squared defined by this. So this, we have negative 1/4. So we have a couple of things going on. So this negative 1/4, it's actually doing a couple of things. First, it is negative. So we have a negative in front. We have a flip over the x-axis, okay? So it's going to flip over the x-axis, and then it's a fraction. So it's going to be shrinking. And then we have this negative 3, which is inside. So it's going to do a horizontal shift of the opposite sign. So it's going to move to the right, positive 3. And then we have a outside number. So it's going to be a vertical shift with the sign. So we have a couple of things going on. Let's do it in pieces. We have this going on. We have this going on. And then we have this going on. So again, with the 1/4, this is telling us it's going to be a shrink. And flip over x-axis. It's going to be a shrink and a flip over x-axis. The shrink comes from the negative. The shrink comes from the fraction, and then the flipping over x-axis comes from the negative. This minus 3, this is telling us we're going to shift to the right by 3. And then this 10 is telling us to do a shift to the, oh, not to the, shift up by 15. Okay. Okay, number 10. Describe each transformation of the parent function. P of x is the absolute value of x defined by h of x minus 2.5 times this whole thing. Okay. Again, let's break it up into pieces. We have a negative 2.5. We have a positive 5. And then we have a negative 8 outside. So here we don't have parentheses, but we do have absolute values, and we could treat it very similar to parentheses. So we have this negative 2.5. Okay, it is negative. So which one are we going to do? Negative flips it over the x-axis. So this is it's going to flip it, and then 2.5. So is that bigger than 1? Yes. So it's going to be a stretch and flip over x-axis. The plus 5 is a shift to the, not right, to the left by 5. Okay, and then this last one, negative 8. Since this is outside the absolute value, we do exactly what it says. So a shift down by negative 8. Okay. So example 11, identify the key features of the graph of the function g of x is equal to negative 4x minus 2 squared minus 8. Okay. So that's a handful. And then wants us to identify the vertex. Is it opening up or down? Stretch or shrink? Okay, so for this one, we have a negative in front. We have a negative 4 in front. So a parabola always looks something like this, right? It's pointing up, unless, right? This looks x squared, unless we have a negative in front. If there's a negative in front, it's going to face down. That's the only way it's going to be facing down, if there is a negative in front. Is there a negative in front of our g of x? The very front. Is there a negative? Yes or no? Yes, there's a negative 4. So we know it's going to go down. It's going to be facing down. Over. Opens down. Okay. And is the 4 a fraction? It's going to be a stretch. So open down. Now we got to worry about this vertex. Well, how do I find the vertex of this? This is where we solve for x on this one. X minus 2, we set it equal to 0. And we get x equals 2. This is going to be my x value. My xy. My x value is going to be 2. Now, how do I find my y value? Well, I just got to plug it in. So g of 2, I plug in whatever my x value is, I plug it in, and then whatever I get out, that's my y value. So g of 2, I'm going to plug it in. Then get a 4, and then instead of x, I'm going to write 2, and then minus 2, squared minus 5. Okay, now we just got to simplify this. Negative 4, and then 2 minus 2 is 0 squared minus 5. Now I have negative 4 times 0 squared. 0 squared is 0, so negative 4, 0, minus 5. Negative 4 times 0 is 0, minus 5, and then negative 5. So my y value, my g of 2, is negative 5. Okay, now we're on page number 4, and we're looking at key features of linear functions, quadratics, and polynomials. So, for linear functions, right, this could be something like f of x is equal to x plus 1, or maybe it could be f of x is equal to 7x minus 3. So, the highest power of linear functions, the highest power of x is 1. Okay, for quadratics, we want to look specifically at axis of symmetry, right? Quadratics could be something like this, right? Or maybe something like this, or maybe something like x minus 3 squared plus 1. These are all types of quadratics. And then polynomials is the one where we have x minus 4 squared, x plus 3, x minus 3 to the third, and then all of these things. The ones where we have multiple things going on and bigger and bigger exponents. Okay, so linear functions. What we want to be to find what we want to know about linear functions is how to find x-intercepts and y-intercepts. So to find x-intercepts, we set f of x equal to 0. We set f of x equal to 0 to find our x-intercepts, and to find our y-intercept, we set x equals 0. So an example would be here. X, let's do the top one. 7x minus 3. To find the x-intercept, I set f of x equal to 0. So we're going to set the whole equation equal to 0. 0, 7x minus 3. And then you just solve for x at the very end. To solve for y-intercepts, we plug in x equals 0. So we plug in, we find f of 0. So we're going to get 7, 0, minus 3, and then whatever number you get, that's your y-intercept. Okay? For axis symmetry. For axis symmetry, we used the vertical line given by x is equal to negative b over 2a. Okay, so an example of this would be something like x squared plus 2x plus 1. Well, my a value is going to be the leading coefficient, 1, and then my b is going to be my middle term, and then c is equal my last term. So then my axis of symmetry is equal to negative 2 over 2a, and simplifying this, we get negative 1. So an important thing, this is an equation. It's an equation. So we should have x equals blank, not just a number, x equals blank. Okay, and then polynomials and behavior. So polynomials are always going to be smooth. They're always going to either look like this, right? They're going to look something like this, or if I put a negative in front, it's going to look something like this. So there's 4 types of behaviors. We could go from negative infinity to positive infinity, or negative infinity, or positive infinity to negative infinity. Or we can have both of them pointing up or both of them pointing down. And this goes back to our multiplicity, or our behavior, or our degree, and leading coefficient. Okay, now let's do number 12. Given 3 forms of the same quadratic equation. So these are the same quadratic, just going between both different forms. So name each form of the function. So this one is called standard form. We call it standard form because this is how a quadratic is written, and whenever we're talking about general quadratic, it's decreasing in powers of x. We have a power of 2, we have a power of 1, and then here we have no power. Now here, when a quadratic is written like this is what we call vertex form. When a quadratic is written like this, we call this factored form. So we have 3 different forms: standard form, vertex form, and factored form. So we have different forms of the same quadratic because different forms give you different key information. So here, to find the zeros of a quadratic, the easiest one to have it written is in factored form. It's in factored form because here I just set both of these equal to 0 and solve for x, and we get my x's. To find the y-intercept, we use standard form. Standard form. We use standard form for the y-intercept because if I plug in 0, 0 squared is 0, plus 6 times 0 is 0. So we're left with just 8. So here, a standard form gives me the y-intercept automatically. And then finding the axis symmetry, we use standard form as well, because we need to be able to know what my A, B, and C values are, and that only comes out in standard form. And then the vertex form, that's where we use vertex form. So given the function above, so these, find the zeros. Okay, so to find the zeros, we said vector form, so we're going to look at this one. Set this one equal to 0, x plus 2 equals 0. Set this one equal to 0. We get x equals -2, x equals -4. So we have x, find our zeros are x equals -2 and x equals -4. Find the y-intercept. Here, we're going to use this one. So we're going to plug in f of 0. This is 0 squared plus 6 times 0 plus 8. 0 squared plus 6 times 0. This is all 0 plus 8. So we have our y-intercept is, so y is equal to 8. And then my axis of symmetry, this is, again, vertex form. So here my A is 1, my B is 6, and my C is 8. So then my axis of symmetry is going to be x equals -b, which is 6, over 2a, which is 1, which gives us -3. So x equals -3, and then the vertex comes from this one. This one, we set it equal to 0, x plus 3 equals 0. We get x equals -3, and then just -1. Oh, my bad. So x minus 3, axis of symmetry, we solve this to get x equals -3, and then finding the vertex, the x value is always going to be my axis of symmetry, and the negative, to get my y value, I just plug it in. If I plug in -3 here, I get -3 plus 3, 0 squared, so 0 minus 1, -1. Okay, example 13. G of x is equal to 1/2 x minus 2 squared, x plus 3 squared. Complete the following. Identify the degree of g of x. So here, we are going to add the multiplicities. So we're going to, let me use a different color. We're going to add multiplicities. Okay, we're going to add the multiplicities. So that means we're going to add the exponents. Here, I have 2. I have 2. And then here, I have 3. So 2 plus 3. 2 plus 3 is 5. So we have a degree 5 polynomial. Part B, identify the leading coefficient of g of x. Here, we just need to figure out the leading coefficient. I just grab our leading number, so 1/2. And then our leading coefficient of my first factor. So this is going to be 1. And then we keep the exponents the same. And here, 1 squared. And then we just simplify this. This gives us 1/2. So positive. Okay. Part C, determine the x-intercepts and the y-intercepts. The x-intercepts, we just have to set these equal to 0. So from this one, we have x equals 2. I'm skipping some steps, but I think at this point we could skip a few. So here we set it equal to 0 and then solve for x. So x equals 2 and x equals -3. So we have x equals 2 and x equals -3. Okay, so now to find the y-intercepts, I just plug in 0 again. So I have 1/2, then 0 minus 2 squared, 0 plus 3 squared. So let's see what we have. 1/2, and then 4 squared, well, -2 squared, 3 squared. So I have, let's see, 1/2, 4, 9, 36 divided by 2. So we have 1/2 times 36. And what is that, 13? No. Yeah, I think it's 13. No. No. What am I doing? 36 divided by 2. 18. My bad. 18. And then y is equal to 18. Okay, determine the x-intercepts. So we said it was x equals 2. And this has multiplicity 2, which is even. And then the other root is -3 with 2, which again is also even. And now we're going to put everything together. So x equals 2. 1, 2. This is 2. And then 1, 2, 3. -3. And then determine the end behaviors. So degree 5, we know it's going to be degree 5. It's going to be something like this. Okay. So we're going to add 2, and then since it's positive, it stays like this. There's no reflection. So we know at the end behavior, it's going to go something like this. And then here, we know at 2, since A has an even multiplicity, it's going to be something like this. Oh, wait. No, my degree is not 5. This should be 2 plus 2. Oh, 2 plus 2 is not 5, it's 4. Okay, 2 plus 2 is equal to 4. So then our graph isn't going to look like this. It's going to look something like this. And since it's positive, there's no reflection, so it stays like this. Okay, this is way better. Like this. So at 2, it's going to do this. It's going to touch it. And then here, it's also going to touch. So now we got to connect it. And then at 18, let's say it's somewhere right here. 18. It's going to look something like this. Okay. So let's try another problem. So identify the degree. So we're going to add up the multiplicities. We have a 1 up here, 1 plus, and then multiplicity of 2. So we have degree 3. Okay, so if it's degree 3, it's going to look something like this. But it could flip over the x-axis if we have a negative, just like what we have here. So we have a negative 3, and then a 1 to the 1 power, and then a 1 to the squared power, so we get negative 3. So this negative 3 is telling me it's going to flip. It's going to look something like this, right? We flip over the x-axis. So it's going to look something like this. Okay. So determine the x and y intercept. So from here, we have x equals negative 2, and from this one, we have x equals 1. X equals negative 2, x equals 1, and then to find the y-intercept, I plug in 0. So plug in g of 0. I get negative 3, 0 plus 2, 0 minus 1 squared. I get negative 3. 2, negative 1 squared. I get negative 6. Negative 1 squared. So negative 6. I get negative 6. So this is my y value. Negative 6. And then now looking at our x-intercepts. So x equals negative 2. I have multiplicity of 1. So it's going to cross. And at x equals 1. We have multiplicity of 2. So it's going to touch. Okay. So now let's put everything together. X equals negative 2. We have negative 2 right here. Negative 2. And then we have 1 here. And we know it's going to look something like this. So we know it's going to go... Oh. We know it's going to look something like this. So we know our end behavior is going to be somewhere up here. And then our end behavior up here, it's going to look something like that. Now we just got to fill in the gaps. And then y-intercept is negative 6. So let's see. Let's say negative 6 is right here. And then we're going to come, and then at 1, wait. Yeah, so at 1, we're going to have multiplicity of 2, so it's going to touch this point. So it's not going to cross it, it's going to touch it, and then it's going to go back. And then at negative 2, it's going to cross, so we know it has to hit the y-axis. It's going to go here, and then it's going to cross. Okay, now I'll just put everything together. And it's going to look something like this. Okay, let's do another one. Complete the following. So identify the degree of g of x. So we're going to add up the exponents, and we get 2 plus 3 gives me 5. So it's degree 5. Identify the leading coefficient. So here we have an invisible 1. With an invisible 1. And then we have an invisible 1 again here. An invisible 1 again here. 1 squared, 1 to the third. And then we have this one. So since it's a degree 5, it's going to look something like this. It's going to look something like this. And then since it's a positive, there is no flip. So it stays like this. So we could actually just skip, go here. We know it's going to go here. And it's going to go down. Okay. Next, determine the x and y intercepts. So here, x minus 1, x equals 1, x equals 3. So we have 1 and 1, 2, 3. So 3, 1, x equals 1, x equals 3, and then the y equals, well, we got to plug in 0. We plug in 0 to this, we get 0 minus 1 squared, 0 minus 3 squared. Oh, I don't have space. G of 0, 0 minus 1 squared, 0 minus 3 squared, 1 squared, negative 3 squared. I get 9. Positive 9. So 9, and let's say 9 is right here. So at x equals 1, we have multiplicity of 2. So it's going to touch. And at 3, we have multiplicity of 3. So it's going to cross. So 1, it's going to cross. So since it's coming from top right, it's going to have to cross. It's going to go down. And then, wait. Did I do something wrong? It's going to cross. Okay. Oh, that's what it is. This isn't a power 2. This is power 3. Power 3. So this is at 9. It's negative 27. Negative 27. Negative 27. My bad. Negative 27. So we know it's going to come from the top right. It's going to come down. It's going to cross. It's going to hit this point. But before it hits that, it needs to hit this point again. So it's going to come back. And then it's going to hit. So it's going to look something like this. Okay. Yeah. So here I had a power of 2 when actually it's a power of 3. Okay. So double check your powers, and when you're plugging them in, double check your work. Okay. Okay, number 16. So before we do number 16, I want to review some key features of this. Here. So I want to find the zeros of this function f of x. I want to find the zeros of this. So which one is the best one to find zeros? We want to use, to find zeros, we want to use factored form. So factored form looks something like this. It's broken up into its factors. So if I want to find the zeros, I want to factor. So I want to factor, there's no GCF, so I could continue with first times last. We get 25. 1 times 25 is just 25, and then negative 10. Let's see, what do we get? Negative 5, negative 5. Okay. We could do x squared minus 5x minus 5x plus 25. Group the first two, I get x out. Then the next two, these two, since this is a negative, I want to factor out negative, and 5 goes into both. Then I get x minus 5. Oh, 5. Now I factor this one out and this one out as x minus 5. Scribble it out. X. Scribble this one out. Minus 5. And we have x minus 5 squared. Okay. Oh, I got carried away and I just factored and I didn't even answer the question. So we have this, and we could rewrite this as f(x) is equal to x squared minus 10x plus 25. Right? These are the same thing. So we have, and then after all this, we simplified it into x minus 5. Okay, from here, to find the zeros of this, I just set this equal to 0. And here, I just set the bottom equal to 0, or not the bottom, the inside equal to 0. So x minus 5 equals 0, and we get x equals 5 as the only 0 for number 16. Okay, so number 16, the zeros is just 5. Okay, number 17. So I want to solve for x. If I want to solve for x, I need to find the zeros. And if I want to find the zeros, I will want to factor. But I can't factor because it's not in standard form yet. So we got to rewrite this a bit. So x squared plus 5 minus 6x. Let's move everything to one side. X squared plus 6x plus 5 is equal to 0. And now I want to factor. Again, 1 times 5 is 5. Then the inside, and then it turns out it's 1 and 5. Okay, so here I rewrite this as x squared plus x, or 1x, plus 5x plus 5 is equal to 0. Group the first two, what do they have in common? Just x. So we have x plus 1. And then the next, they only have positive 5 in common, so we have x plus 1 is equal to 0. Take out the x squared, x plus 1. And then scribble it out. I get x, and then plus 5. So then my zeros are going to be, I set each one equal to 0, and I get x equals negative 1 and x equals negative 5. Okay, so number 18 is another way to factor, or it's not factoring, it's completing the square. It's how do I find the vertex using completing the square? So for this one, I want to give myself some space a bit. So here, f of x is equal to x squared. So I'm going to write the function exactly how it is, but I'm going to give myself some space. Plus 6x, some space, plus 9. Next, I want to divide this number by 2. And then 6 divided by 2, just a number. 6 divided by 2 is 3. And then we square it and we plug it back in. So 6 divided by 2 is positive 3. If I square positive 3, I get plus 9. And if I add 9, that's going to change my equation. If I just add 9 up here, this becomes 18. So I need to cancel it out. And the way we do that is if I add 9, I'm going to subtract 9. Okay, so it's not because of this 9 over here. This could have been any number, but here, this 9, this plus 9 came from this 3 squared. So if I add 9, I'm going to subtract 9. And then everything else just comes down. This becomes x. And then we have plus 9 minus 9. And now I just simplify. I get x plus 3 squared. And then 9 minus 9 is plus 0. So then our vertex is going to be, well, it's going to be, I set this whole thing to 0. So x plus 3 equals 0. So then x equals negative 3. So x, y, we have negative 3. And then to find my y value, it's just going to be this number. So 0. Okay, number 19, apply completing the square to the algebraic expression x squared plus 8 plus 10. Okay, so we're going to do x squared plus 8x and then space and then plus 10. So I'm going to divide by 2. Positive 8 divided by 2 is positive 4. Square this, plus 16. So if I add 16, I got to subtract 16. So then bring the x down, and then we have plus 10 minus 16. We get x plus 4 squared plus 10 minus 16 minus 6. And there we go. So number 20, use the quadratic formula to solve the zeros of this expression. So first, we gotta write it in standard form. It's not in standard form because we have this positive 12 on the right side, and we want everything on the same side. So if I write this real quick as x squared plus 4x minus 12 is equal to 0, now we can apply quadratic formula. So here, my a value is the very first number, so 1. My b value is 4. And my c value is negative 12. And now the quadratic formula, this is given by x is equal to negative b plus or minus b squared minus 4ac. So the square root of all this all over 2a. And now I just got to plug it in. So negative b, so negative 4 plus or minus b squared, so 4 squared minus 4ac, and that's negative 12, and then 2, and then a is 1. So again, negative 4 plus or minus 16 minus plus 48 all over 2. Okay, and using a calculator to simplify this a bit, I get negative 4 plus or minus square root of 64 over 2. So negative 4 plus or minus 8 over 2. And now I split this into 2. So I do -4 plus 8 over 2 and -4 minus 8 divided by 2. This gives me 2. -4 plus 8, that's 4 divided by 2, 2. 12, -6. So then my final answer is going to be x equals positive 2, x equals -6. Oh. X equals 2 and x equals -6. So here, I just plugged it into the formula, right? My ABC values into this, and I get plug it in, simplify, and then after this, I just simplify. It's just simplifying, and then it's here where I split up my plus and minus into -4 plus 8 divided by 2, which gives us 2, and then the other one is -4 minus 8 divided by 2 gives us -6. So then our answer is x equals 2, x equals -6. Okay, so 21. Use the quadratic formula to solve for the zeros of h of x. Okay, first, is it written in standard form? Good, it is written in standard form. So now we got to label our A. A is 1, B is 5, C is equal to 8. So then now I just plug it into the quadratic formula. Let's see, let me align this. Negative b plus or minus b squared minus 4ac all over 2a. There we go. That is my quadratic formula. So next, I just plug it in. So let's see, what do I get? Negative b, so minus 5 plus or minus 5 squared minus 4ac 8 all over 2 times 1. Okay. Now we have -5 plus or minus 5 squared, 25 minus 4 times 1 times 8. So what does this give us? What does this give us? Mm, 25 minus 32. Yes. 32. All over 2. Yes. Okay, so then this becomes -5 plus or minus. Oh, we have a complex number. We have -7 inside. So then this becomes, let's see, -5 plus square root of -7 over 2 and -5 minus square root of -7 over 2. And then depending whether or not your instructor or your teacher has gone over square roots and negative, we could simplify this even more into -5 plus I square root of 7 and -5 minus I square root of 7 all over 2. But for the most part, this should be fine. So we have one answer, we have two answers. So x equals this, and x equals this. Those two should be fun. Okay, and then the very last problem. It's a challenge questions I left open for anyone to attempt. It is not required. You're not going to get graded on this. But it's a challenge question. But if you do get an answer and you submit it, just turn it in to me. I know Mr. Olivas and Estrada will be using this video. So if any of you guys want to attempt it, you guys could attempt it, show it to Mr. Estrada or Mr. Olivas, and then he could forward your solution up to me. And then if you get it right, or when you get it right, I'll think of a reward, or a prize for solving it. Okay, so it's a challenge question, the big G polynomial. Attempt it. If you're able to attempt it, it means that you will do really well on the exam. Okay. So again, if you have any questions, leave a comment or ask me to go over the specific problem one more time. But this is just a broad overview of the study guide.